Welcome to this video on quantile-quantile plot or QQ plot in short. We will learn the detailed process of creating a QQ plot and see how to interpret the QQ plot to see if the data follows a certain distribution. Let's first review the concept of quantile. Quantile is the value below which a certain percentage of the data falls. For example, the median is the value below which 50% of the data falls. The 25% quantile is the value below which 25% of the data falls. The 75% quantile is the value below which 70% of the data falls. The quantile function is essentially the inverse of the cumulative distribution function. Next, we will see the step-by-step process of creating a QQ plot. First, we import the necessary libraries, NumPy, Matplotlib, and the SciPy statistics. Then, we generate a sample data from a normal distribution with mean 0 and standard deviation 1. We then sort the data from the smallest to the largest. We plot the sorted data in a scatter plot against the index and make sure that the sorting process is correct. The sorted data is shown here. The step 2 is to calculate the percentiles of the sorted data. The percentile is the percentage of the data that is below the value. Suppose that we have n data points. For the smallest value, the percentile is 1 over n plus 1. And for the largest value, the percentile is n over n plus 1. The percentiles are shown here. The step 3 is to calculate the theoretical quantiles from the distribution. For example, if we want to compare the data to a normal distribution, we can use the quantile function of normal distribution to calculate the theoretical quantiles. For each percentile, we calculate the theoretical quantile by using the quantile function. The theoretical quantiles are shown here. The step 4 is to plot the theoretical quantiles against the sample quantiles. Actually, the sample quantiles are simply the sorted data. The QQ plot is shown here. We can see that the scatter points are close to the straight line y equals x. This means the data quantiles are approximately equal to the theoretical quantiles, which indicates that the data follows a normal distribution, which is expected. Next, we consider a case where the data does not follow a normal distribution. We generate a sample data from the student t distribution with 3 degrees of freedom. We sort the data from small to large. Then we compare the sorted data to the theoretical quantiles of the normal distribution. We first calculate the sample mean and the standard deviation. Then we calculate the theoretical quantiles by using the quantile function of the normal distribution with sample mean and standard deviation. And then we plot the theoretical quantiles against the sample quantiles, that is, the sorted data. We can see that the scatter points are not close to a straight line y equals x. Significant deviations is observed at the tails of the distribution. The sample quantiles are significantly greater than the theoretical normal quantiles in absolute value at the tails. In other words, at the same tail threshold, the tail probability of the data exceeding the threshold is greater than that of the normal distribution. This means that the data has heavier tails than the normal distribution. Next, we generate the QQ plot of the data against the student t distribution with 3 degrees of freedom. We can see that the scattered points are close to the straight line y equals x. This means the data quantiles are approximately equal to the theoretical quantiles, which indicates that the data follows a student t distribution with 3 degrees of freedom, which is expected.